At dawn, a tiny octopus breaks free from its egg sac. Unfurling 8 microscopic arms, it begins its ascent toward the sunlit surface. No parent to guide it, no pack to protect it, no social structure to teach survival. To navigate a reef swarming with predators, the hatchling relies on a combination of raw instinct and an immediate, advanced curiosity. From the moment it hatches, its reality is defined by absolute isolation. Every decision is made entirely alone. High intelligence typically requires a long lifespan and complex social network. Humans, elephants, and whales cluster here, utilizing decades of social learning. But the octopus is an outlier. It occupies the top left, possessing complex cognitive abilities while living briefly and entirely in solitude. This creates a biological mystery. There is no clear evolutionary reason why a creature that lives such a brief, lonely life would need a mind this capable. As a soft-bodied animal in a reef filled with apex predators, the octopus is physically defenseless. It lacks the shell or speed that protects other mollusks. To survive, it uses its mind to vanish. The skin physically transforms in a fraction of a second, shifting from smooth and pale to a textured, vibrant pattern that mimics the surrounding coral. If the camouflage is compromised, it deploys a secondary tactic, a precisely timed cloud of dark ink that masks its escape route. This is not a passive biological reflex. It is an active manipulation of the environment, where the octopus controls exactly what a predator is allowed to see. This intelligence is proactive. An octopus will forage for discarded coconut shells, dragging them across the seafloor to assemble a mobile fortress. Its arms can solve mechanical problems independently, like maintaining a firm grip while unscrewing a jar to reach the food inside. This is possible through a decentralized nervous system. Most neurons are actually distributed throughout the 8 arms. Each sucker processes sensory information independently. They taste and feel locally, sending data to the arm's nerve cord without consulting the central brain. This distributed mind allows the octopus to manage multiple complex tasks at once. Every touch becomes a search for information, and every color change an active response. During the night, the octopus retreats to a crevice in the reef to rest, entering into a state of deep vulnerability. Even in sleep, the skin continues to pulse. Rhythmic waves of neon blues and golds wash across its mantle in a continuous cycle. Scientists observing these rapid, involuntary color shifts have noted their similarity to REM sleep in mammals. It suggests the brain is engaged in active internal processing. These moments indicate that octopus intelligence isn't just a survival tool for the waking world, but a persistent internal experience that continues even when the animal is at rest. Every octopus eventually reaches a final biological destination. The female retreats to a secluded den to lay thousands of eggs. She stops hunting. Her physical health declines rapidly as she spends her final weeks cleaning and aerating the egg strings, protecting the next generation from scavengers. This phase is known as senescence. Her high-functioning nervous system was the biological engine required to navigate the world just long enough to reach this single reproductive event. Her life cycle prioritizes rapid cognitive development over longevity. The energy that might have sustained her for decades is instead used to ensure her eggs survive to hatch. As her life ends, she leaves a final, intricate pattern of ink in the current, a silhouette drifting upward toward the surface light. In the ocean, success doesn't always require lasting a lifetime. For the octopus, it means using a brilliant mind to navigate a short, solitary journey before returning to the